This is Calculus 2 class. We are working on the sequence, series, and series test this module. First, we're going to start sequence. Let us start with definition of a sequence. So we call sequence or infinity sequence. What does a sequence means, guys? Look at this definition right here. Sequence is list of number written in the definite order. So here is they write in the order. Here is A1. One meaning is the first term. A2, that's the second term. A3, that's the third term. This one we call general term. We usually say nth term. So not only A1, A2, A3, sometimes they write B1, B2, B3, or C1, C2, C3. Index is number 1 to 3, meaning it's the first term, second term, third term. Sometimes they have a set notation. This is a set notation. Or simply an, meaning it's a stop point, n equal 1 to infinity. Infinity meaning is sequences keep going, a first term, second term, third term. Another infinity series we're gonna see very often is alternating series. Alternating series is gonna be alternating sequence, meaning it's not series. Sequence is sign is alternating. Right here, guys, look at the first term is positive, second term is negative, third term is positive, or first term is negative, second term is positive, third term is negative. So sign is alternating. We call alternating sequence. Sometimes you're gonna see this form, an equal negative 1 nth power bn. Bn is a positive. Sometimes they write it negative 1 and n plus 1 bn, or negative 1 n minus 1 bn. So alternating sequence meaning is they alternating sign. That's alternating sequence. Now let's investigate the sequence. First one is right here, guys. Let's practice how can write the term of sequence. First one is write down here. First one is gonna be, here is 1 over 2n, an is 1 over 2n, n equal 1, 2, 3, 4, 5. Never stop, guys. So let's write down the third term. N equal 1, n equal 2, n equals 3. You keep going. So n equal 1, plug in the 1, a1 first term, 1 over 2. N equal 2, a2, 1 over 2 to the 2 square. So that's gonna be 1 over 4. A3, 1 over 2 cubed, 2 times 2 times 2, that's 1 over 8. That's the third term. Let's go practice n equal 10, meaning is A10, 1 over 2, 10. So index is in the here, that's represent term. A1 is value, first term value, second term value, third term value. Let's practice B, same thing here, guys. Here, n over n plus 1, they start n equal to, it's okay. Not always start 1, so n equal to, here is A2, 2 over 3. N equals 3, A3, 3 over 4. Let's go, n equal 10, A10, that's gonna be 10 over 10 plus 1. That's going to be 10 over 11. So if you know the sequence, you know the any terms, plug in the m value. That's how to find each term of a sequence. Let's just practice more sequence. So, okay, this one is the square root n plus 1. So n equal 1, n equal 2, n equal 3. You just practice, write the 3 term of a sequence. First one is A1, square root 1 plus 1 is 2. A2, square root 2 plus 1 is 3. A3, square root 3 plus 1, that's the 4. So this one is, you see the pattern. It's sequence has a pattern. like this. Next example is gonna be an is -1 and n over 2n. This one represents gonna be, it might show the alternating sign, guys. Let's see how they show the each term. So n equal 1 stop point, a1, -1 and 1, 1 over 2. So -1 times 1 is -1 over 2. That's the first term. N equal to a2, -1 square times 2 over 2 square, -1 square positive, 2 square is 4, n equals 3, a3, -1 cube, 3 over 2 cube, that's gonna be -3, 2 cube. See that? That's just keep changing the sign, negative, positive, negative. So we call this is alternating sequence. Okay? So another tip about sequence is you're looking for the pattern of each term, then try not to simplify to look for a pattern. This example is the sequence doesn't show the general term. They show list of numbers. So now you have to find the pattern of this sequence. So there are so many different ways find the pattern. You might trial errors. Guys, the first one is look at this. A1 is 1. A2 is 1 over 3. A3 gonna be 1 over 9. A4 gonna be 1 over 27. Your goal is what is an? So when you plug in the n, what is looks like this sequence? So 1, because all numerate is 1, first term is 1 over 1. Let's very carefully 1, 3, 9, 27. Denominator is 1, 3, 9, 27. So you're looking for a pattern different way, but here is 1 times 3, 3 times 9, okay? So this one, another way to write down, 1 over 3 square. This one is 1 over 3 cube. So look at this number, index is 4, here is a 3. Here is the 3, here is a 2. Here is a 2, here is a 1. So I figure n, index is nth term, gonna be 3 n minus 1. That's gonna be you write the general term. So find the pattern is so many different way, guys. You might guess and try or error. So the second one, let's try this one too, same way. So A1 is 10, A2 is 10 over 2. So I'm gonna rewrite the first term 10 over 1. A3 gonna be 10 over 3. A4 gonna be 10 over 4. Guys, can you see the pattern, guys? So what if an gonna be? All numerator have 10. Denominator, first term is denominator 1, second term denominator 2, third term denominator 3, fourth term denominator 4, nth term denominator gonna be n. That's you figured it out, the general term of a sequence. Let's practice more, guys. First, you just identify this sequence. This is a list of number. You notice this sign is alternating. So look at this one. Here is a positive, here is a negative, positive, negative. So you know that this is alternating sequence. Then you see, first term is going to be 1.5. A1 is 1.5. That's a positive. A2 gonna be -2 over 3. A3 gonna be 3 over 4. A4 gonna be -4 over 5. You're gonna looking for the AN term. First, you decide the negative alternating sequence says -1's power. You have to decide this power first. First term is a positive. Second term is negative, which meaning is n is 1 positive, so you probably power gonna be even number. So n equal 1, 1 plus 1, even number, -1 is make a positive. That's you decide first. Then, now you decide the sign. Now look at that. First term is 1 over 2. Here is 2 is 2 over 3. 3 is 3 over 4. So look at this one. You're going to rethink about this sequence. 1, 1 plus 1. 2, 2, 2 plus 1. 3, 3 plus 1. Can you see the pattern? So this gonna be 2 and 2, 3 and 2. That's numerator, right? N is index n. Bottom is bigger than 1 of the index, so n plus 1. That's you find the general term of this sequence. Okay? What is how to find it? First, look at the sign. Sign is all positive? No. Alternating, then decide this term first, guys. Decide this term first. Then you're going to see pattern of each term. That's you find the general term of sequence. Let's do next one, guys. Look at this one. This one is C gonna be positive, negative, positive, negative. This one is negative, positive, negative, positive. So this case, how can decide the power of -1 gonna be A1 gonna be -1, A2 gonna be 1 over 4, A3 gonna be -1 over 9, A4 gonna be 1 over 16. So AN gonna be first decide part of -1. First one is negative, second is positive. Here is n. This gonna be n, exactly same. Even number is positive, even term is positive, odd number is negative. So negative n power. Now, thinking about 1 over 1, because all the fraction, 1 over 4, let's write it. 1 over 2 square, 1 over 9, 1 over 3 square, 1 over 60, 1 over 4 square. Fourth term, 4 square is denominator. So this one is 1 over n square. So this general term of this sequence, -1 n square. Okay, that's you find the pattern. Don't discourage if you cannot find the pattern right away, but you just keep try the trial error, then you're gonna find the general term. There is a two special sequence. One is arithmetic sequence. Second is geometric sequence. So first one is arithmetic sequence. Arithmetic sequence. Second is geometric sequence. Let's explain first. What is arithmetic sequence first? Arithmetic sequence is gonna be arithmetic sequences, for example, A1 is gonna be 1, A2 gonna be 3, A3 gonna be 5, A4 gonna be 7. So can you see the pattern, guys? Pattern. So you're gonna add, what do you add here? A1 to the A3, you add 2. A3 add, A3 gonna be A2 plus 2. A4 gonna be A3 plus 2. That's we call arithmetic sequence. Each time you add, we call this is different, common different. Each time you add D, it can be negative, it can be positive. So find the AN. How can find AN gonna be, guys? You keep adding D n minus 1 times, okay? So A1 plus n minus 1 D. That's you find the arithmetic sequence. General term of arithmetic sequence. What is geometric sequence? Very simple example is A1 is 1, A2 gonna be 2, A3 gonna be 4, A4 gonna be 8. What is the pattern of these sequences? You times to each time. So this one is a common ratio. Each time you times R, so AN gonna be A1 times R n minus 1. That's you're gonna find the general term. But what is more important, sequence here in the future, guys. So Please, really important sequence from now on is geometric sequence, guys. Let's do this example. Which one is arithmetic sequence? Which one is geometric sequence? Find the general term. We talk about what is geometric sequence, arithmetic sequence, right? So arithmetic sequence gonna be add the same number, okay? Add. This can be negative, positive, okay? Geometric is multiply. This is greater than one number, less than one number, okay? That's the arithmetic sequence, geometric sequence. How can find general term? You're gonna find general term is A1. You're gonna find difference or common ratio. That's the keep in mind we're gonna looking for. So let's go first one right here. 4, 8, 16, 32. What kind of pattern you're gonna see, guys? Here, 4, 8. 8, 16, 16, 32 times 2 each time, right? Times it. That's the geometric sequence. So you find the common ratio R. What is the first term is A. So A1 is 4. R is 2. General term is 4 times 2n minus 1. That's the general term. You want to simplify, you can simplify, you don't have to. So that's the general term of this sequence. How can check? You plug in n equal 1, A1, 4 times 2, 1 minus 1, 4 times 2, 0. That's the 4 times 2. 0 is 1, right? I almost make a mistake. That's 4. Did you find the A1 is 4? Let's try n equal 2. A2 gonna be 4 times 2, 2 minus 1, 4 times 2. That's it. You're right. So this one is general term of this sequence. Let's go to B. B gonna be, let's check here. B gonna be 10, 15, 20, 25. Can you see it? Add 5 each time. So D gonna be 5. So A1 is 10. So AN gonna be 10 plus n minus 1 times 5. 10 plus 5n minus 5. This one is 5n plus 5. You wanna check that this general term is right or wrong? You're gonna plug in n equal 1. A1, 5 plus 5, 10. Right? This first term is 10. N equal 2. A2 is 5 times 2 plus 5, 15. So you find the right general term right there. AN is 5n plus 5. That's the popular sequence. But as I said, geometric sequence is important. What is so important here, guys, from now on? Make sure you're going to find the first term, you're going to find the common ratio. We studied the definition of sequence, and we also investigate the geometric arithmetic sequence, how we're going to find the pattern, how we're going to figure it out general term of sequence. Now, our attention is behavior of sequence, guys. Now, we call limit of sequence. This limit of sequence, another way say, and behavior sequence. So this is a sequence right here, guys. Look at this. N over n plus 1. You see, this is the first term. Let's say this is the first term, A1. This is A2 second term. This is A3. This is A4. Though each term we can figure it out, but we really know this sequence and the behavior. So I'm gonna sketch this one on here, guys. How can sketch the sequence on the coordinate plan? This one represents index. Index is each term, n equal 1. N is gonna be 1. First term is this represent A1, 1 over 2. This one is 1 over 2. N equal to second term, this one represent A2. That's gonna be 2 over 3. Here is n equal to 3. This is A3, 3 over 4. Okay, that's I sketched the sequence on the coordinate plane. Can you see this behavior, guys? Look at this graph. First term, second, third, fourth, getting close to which line? This value is getting close to which line? Getting close to this line, which is here. What is here value? 1, right? That's we call. So this and the behavior of this sequence getting go to this direction and it's increasing 8, 9, 10, 11, 12. This AN behavior, AN getting close 1, right? Horizontal line 1. That's we call limit. So how gonna write it here? And approach the infinity, meaning it's sequence is going on. Then each term, what kind of behavior AN is this sequence going to the 1? So that's the concept of a limit of sequence. So we want to know end behavior sequence, okay? Let's give the formal definition of limit of sequence. Let's I want to give the definition of limit of sequence. So sequence is right there. Sequence AN, so A1, A2, A2, 3. That's a sequences keep going. Keep going. So that meaning is N is gonna be this term is keep going each time. What happened? All the way keep going. What is behavior and the behavior of a sequence? If you find this value of each sequence go to the approach the one value, that's we call limit L. So limit and approach the infinity AN equal to L. Approach the certain number. AN approach to L as N go to infinity, meaning it's a sequence. Each term is keep going. Then what is value of this sequence goes? That's going to one number, getting close to one number. Then we say sequence is converged or sequence is convergent. Otherwise, we're going to say divergent. Divergent have two different things. Divergent is unbounded, divergent is alternating. I'm gonna show the graph, then explain what do you mean by that. Let's illustrate the convergence and divergence. So this one is just sketch the sequence. The first one is convergence. Convergence looks like, guys, this one represents terms. First term, value gonna be here. Second term, value gonna be here. So this one is represent A1, A2, A3. But our interest is what is the behavior of here and the behavior here. Sequence is increasing and decreasing, and we'll approach this each sequence later on. This line, horizontal line, that's L value. Then we're gonna say limit and approach the infinite AN go to L. So and the behavior going to in the last moments, the sequence is getting close, gonna be specific number. That's the limit concept. That's the convergence concept right here, guys. Another one is look at this one. Sequences behavior A1, A2, A3, A4 go up, decreasing, increasing, decreasing, getting close. This the horizontal line. So also this one is an approach to A and go to the L. So we are really interested where this sequence go. What is end behavior? In the end, they close a certain number. That's the convergence. Divergent meaning is here is like this one is A1 right there, guys. A1. So this one is A1. First term is 1. This is A2. This is A3. This is A4. That's gonna be keep first one, second, third one, fourth, but they not close any number here, horizontal line. That's gonna be divergent. Okay, another way limit does not exist. Another great example of divergence is A1 is here, A2 is here, A3 here, A4, but sequence, value of sequence is increasing. So this case, we write it and approach to infinity. This AN sequence behavior is getting increasing. That's gonna be infinity. That's two case divergent case, okay? So keep in mind that in convergence meaning is a sequence. The end behavior sequences approach the certain number. Divergent is alternating, never close one number. The sequence is getting increasing, then this one is going to infinity. That's illustrate convergence divergent. Let's find convergence divergence. This simple way you figured it out. If sequence is convergence, divergence, you plug in the number or you sketch the sequence on the coordinate plane. I'm gonna start two different ways. First one is I'm gonna plug in the number. So an gonna be n. So this one is first term is 1, second term is 2, third one is 3, 4 is 4, 5. Number is what happened to number. You're gonna be keep next term, next term, next term. This number is increasing unbounded, keep going. Increasing we call unbounded. So this one is going to infinity, meaning is number is getting bigger, right? First term, second, third term. This one is divergent. Or you're going to see limit and approach the infinite and going to infinity. All right. Second example is an is negative 1n. Let's find the first term is n equal 1, negative 1. Second term is 1. Third term is negative 1. Fourth term is 1. That's alternating sequence, but not going to one point. So you want to sketch the here. First term is negative 1, second term is 1, third term is negative 1, fourth term is 1, next one is negative 1. 1 never close one horizontal line, one number. So this one is divergent. Okay, not increasing anything, right? That's alternating value. Number C is an is negative 1 and n to the n. Let's find the first term is negative 1 over 1. That's negative 1. Second term is 1 over 2. Third term is negative 1 over 3. This also alternating series. Guys, what kind of behavior n is getting increasing and number each behavior each term what's gonna happen? So you keep going, guys. Look at this. You wanna sketch here. First term is negative 1, that's negative 1. Second term is 1.5. Third term is negative 1/3. Fourth term is negative positive 1/4. Fifth term is negative 1/5. So getting close where? Which horizontal line? Which horizontal line? This one, right? This one. So this limit is gonna be 0. Okay, that's a simple way you find the limit of sequence. You're going to plug in the number, see the pattern and the behavior sequence, or you sketch the sequence on the coordinate plane. This sequence plus which horizontal line, then you're going to see the limit. Before I introduce so many different ways to you find the limit of the sequence, let's briefly introduce property of convergence sequence. Here is you say an has limit, bn has limit, then you're going to add of sequence of limit of sum of a sequence. You're going to find each limit and add together. Add the limit. You have find the limit of difference. You're going to find each limit and subtract. You have scalar multiplication, this coming out to C times this limit of A and C times F. You have a multiplication of sequence, we want to find the limit, then you separate each limit, then multiply of two limits. You have division of sequence, you want to find this limit, You separate limit, then division of limit. Okay, that's we're gonna use this property of convergence of sequence. But one thing really important here is when you're using this property, make sure both sequence has a limit. One of them has if one of them divergent, we cannot use this love sequence.